Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.2, Problem 5. This is Section 11.2, Problem number 5. It says, consider the function f of x equals x plus 6 when the input is smaller than 2, the output is x to the third power when the input is equal to 2, and the output is 5x minus 2 when the input is greater than 2. So this function is defined in 3 branches, which makes it look very complicated. And then it asks, part A, is the function continuous when x equals 2? And part B, is the function continuous when x equals -1? So there's the same 3 questions you have to answer to determine if a function is continuous at any point. So for part A, is the function continuous when x equals 2? Well, first of all, can I put in a 2 as an input and find an output? So as I look at my 3 branches for the function, if I use the middle branch, it says when the input's 2, the output would be x to the third, or 2 to the third, which would be 8. 2 times 2 times 2 is 8. So the answer to question 1 is yes. F of 2 equals 8. If I use 2 as an input, I get an output of 8. So I can put in a 2 and find an answer. The second question, does the limit of this function as the input approaches 2 exist? Now again, to take the limit, I'm not actually putting an input of 2. I'm putting in input values super close to 2. So I have to use values slightly less than 2, like 1.9999. For those, I would use the top branch of the function. And also input values slightly larger than 2, like 2.00001. So I would use the bottom branch of the function. So I have to use both branches to determine the limit as the input gets close to 2. So from the top branch, as I put in values fairly close to 2, the output's going to get fairly close to 2 plus 6, which is 8. Now on the bottom branch, as I put in input values fairly close to 2, the output's going to get fairly close to 5 times 2 minus 2. 5 times 2 is 10, minus 2 is 8. So as I get very close to 2 with values slightly less, the output is getting close to 8. As I get very close to 2 with input values slightly larger than 2, the output's also getting close to 8. So the answer is yes, the limit does exist. The limit of this function as the input approaches 2 is equal to 8. And now the third question, does f of 2 equal the limit as the input approaches 2? Well, the answer is yes, they're both 8. So is this function continuous at 2? The answer is yes, it is continuous. Is continuous when x equals 2. Now, part B, same function. Is it continuous now when x is -1? So same 3 questions. Does f of -1 exist? Can I use -1 as an input and find an output? And I can, actually. So for -1, I really only need the top branch. -1 is smaller than 2. So if I put in a -1, x plus 6 would become -1 plus 6, which is 5, positive 5. So f of -1 is 5. I can put in a -1 and find an output. Next question, does the limit of the function as the input approaches -1 exist? And actually, since -1, I can use input values both a little smaller and a little bigger, all on the top branch. The same thing's going to happen. The output is not exactly 5, but it's going to get really close to 5. As my input gets super close to -1, the output gets super close to 5. So the limit of this function as the input values approach -1 is also equal to 5. And then for question 3, does f of -1 equal the limit of f as x approaches -1? Yes, it does. They're both 5. So for B, it's also continuous. So is continuous when x equals -1. So it's continuous for both. Part A, it is continuous when x equals 2. Part B, it is also continuous when x equals -1.